Next year, you're probably aware that the Rio Grande is kind of in bad shape. I mean, we didn't get good snowpack last year. La Nina is forecast to also be a low runoff. So we expect that there'll be a lot less water coming down the river. The farmers in both El Paso and Las Cruces will be severely impacted. But we will begin to pump more water from the Waco because we started, and we're going to be using water from the Waco. So next year we may be more at 60,000 acre feet or some number, depending upon how much water we get from the river. But obviously the strategy has worked. We've banked the water. We're going to be using the water in times of drought. This is kind of the results of effective conservation and reuse. So again, you can see this is in billions of gallons, but you can see that we're using about the same amount of water as we were using last year. We've had some ups and downs. Whoops. We did have a drought, as most of you know, and we have been in drought on the river, but in 2004 was a pretty low year, and you can see how that shows. Then we had some wet years with the floods in 2006, rainfall in 2007, 2008. The last 3 years have been quite dry, as you well know, in terms of precipitation. But again, this kind of shows the population growth here going up like this. Whoops, I keep hitting the wrong button here. But you can see that the amount of water we're using is the same with this tremendous population growth. So that's what we're really proud of, and proud of our customers who have been able to help us, achieve that type of growth. Let me talk about desalination. We started looking at this back in the early 1990s as part of our long-term 50-year strategic plan. I and others visited a lot of desalination plants in this country, some in other countries. We pilot planted it. We found the water to be very treatable. The issue back then was power. How much power will it take? And basically what to do with the concentrate, the byproduct. We didn't do anything for a few years as we developed some of our other resources. We did a major inventory of the Waco Bolson with the U.S. Geological Survey. We developed groundwater models, which we use today, to inventory the brackish or saline water, and also inventory the fresh water, determine more precisely how much is in storage and which way is it traveling, and how to mitigate any type of saltwater intrusion into the freshwater supplies, which has been a big issue in this area. So once we did all of that, then we were ready to move forward. And I mentioned we approached the Department of Defense, Fort Bliss, and we developed a partnership, working a lot with the Pentagon, and kind of convinced Fort Bliss that if they didn't do some things like we were suggesting, that their freshwater wells would also become brackish in time. So that was the biggest selling point to the Pentagon. I think it probably led to the decision of BRAC, the Base Realignment and Closure, to really expand Fort Bliss once we decided to build that plant, and once the community realized that El Paso was serious about water management, and we had done a lot of work in 20 years in terms of managing our water. So when you look at the $5 or $6 billion worth of investment in El Paso because of Fort Bliss, it kind of shows what we all know, that without water, you don't have economic development. You have to have water to have economic development. And you can talk about everything else that there is to talk about, but I'm biased, but the truth is, if you don't have water, you're not going to have economic development. China just opened a huge desalination plant next to a power plant. They spent several $1 billion on that plant, and the government owns it, but basically they're subsidizing the cost of that water to the consumers, but to them it means economics. If that's the water you have to deal with, that's what you have. And the price of membranes have come down, the membranes we use, because there's more competition, and the process has become more efficient. And so that's why desalination is part of our portfolio. Now, what the Public Service Board, my governing board, is working on, and by the way, Dr. Shapoyster is here. He's a member of my board, very good board member. I'm so pleased that UTEP allowed him to spend part of his time on the Public Service Board. He brings a lot of expertise in engineering and all of his experiences to the PSB. We have done a number of economic analysis along with financial and also engineering work to look at solar powering of the desalination plant. There's not a single plant that I'm aware of in this country or anywhere that has solar powering of a desalination plant. So we've gone through all the work. It's not inexpensive, as you know, on the capital side to build a solar plant. But when you look at the triple bottom line, if you will, and we've done some triple bottom line analysis of desalination and reuse, and the results are outstanding in terms of, you know, what alternatives we have. And had we not invested in reuse and desalination and gone to other alternatives, which is really importing water, what those costs would be. So in the scheme of things, desalination costs a little more money than other alternatives, but in the big picture, it is the right solution for this part of the country. So we're doing that now, evaluating that at the desal plant. So we have 5 skids or 5 trains. Each uses about 500 kilowatts, so about a 2.5 megawatt unit. It's pretty good size. It's not huge, and that gives you an idea of how much demand there is compared to, you know, an industry or a home or a group of homes. But you take advantage of it because we do pay. El Paso Electric has for us. They have time of day rates. We have peak, critical peak, and peak, off peak, and critical peak. And during the summertime, between the hours of 2 and 6 p.m., we're in critical peak, and we're paying 23 cents a kilowatt hour, okay? And you can't stop a desalination plant. So part of our reasoning is to get off that critical peak, which would help El Paso Electric, because they can take that power and use it someplace else as opposed to a desalination plant. So, you know, during the times that the sun shines here during the day, and then there's a lot of sunny days here in El Paso, we're the sun city, right? But we don't really have any type of any size solar plant. El Paso Electric recently has a power purchase agreement with a big plant in Santa Teresa, which when you fly over El Paso, you'll see it because it's a lot of acres, a couple of hundred acres or more. But that's a power purchase agreement. And the reason for that is because you have better incentives in New Mexico than you do in Texas. Texas does not really have an incentive program for alternative energy compared to California, New Mexico, Arizona, and New Mexico. Yes, you're getting close? Okay, I'm going to move on. I think the benefits of solar power there that I told you about. Reclaimed water. We do use a lot of reclaimed water. It uses 12 to 14% less energy to produce reclaimed water than potable water. We have over almost 50 miles of pipeline in the ground. About 2 billion gallons were sold last year, and we are under expansion. You can see how we've grown from maybe a couple 100,000 gallons per year back here 20 years ago to where we are now at 2 billion gallons per day. So it's another area that's drought-proof. There's plenty of sewage. It's a drought-proof supply, just like desalination is, and so we're using it. Wastewater, this is a project that's undergoing, is our conversion of methane gas, you know, to power, to electricity in order to use that beneficially. We have that under construction right now. This is one of the big engine generators as a Waukesha. It's being installed as we speak. They'll be online next April. We expect that we'll produce about 229 million cubic feet of methane gas, scrub it, and then save about $750,000 of power. Research, just real quickly, they talked about this morning about the partnership with UTEP. Several years ago, we established what we call Chihuahua. It's basically Consortium for High-Tech Investigations of Water and Wastewater, CHIWAWA. It's Texas A&M, UTEP, New Mexico State, Alamogordo, and us in doing research in water. And we've done several projects together collectively. We also have the SIDS, the partnership that we have with UTEP that we're doing. There was mentioned that we're partnered with Stanford, Berkeley, and then Carlisle School of Mines with NMSU on this new research project that we're involved in, because I think that research is the way of the future, and El Paso is a living laboratory for water research. When you think about it, when you look at the surface water, the groundwater, the international issues, the potential for reuse, the potential for desalination, we have everything that anybody could offer or have a problem with here in El Paso, and so the opportunity becomes the problem becomes a real opportunity. We have a contract with REDCO, the Regional Economic Development Corporation, to try to locate industry here in El Paso that could do research and also build facilities in the water business, you know, that could be marketed throughout the Americas, throughout the country, wherever, throughout the world. Why not have water-type manufacturing here in El Paso? So in summary, I think conservation not only conserves water but energy. We've got the desalination plant. We're going to go to solar energy with board approval and hopefully have that under construction next year. And I think El Paso continues to be a national leader in water research, and I think with energy, we're working hard we've worked with Los Alamos in the past. We're working with DOE, DOD, Bureau of Reclamation, a number of entities to do that. So with that, thank you very much.
Please go ahead and write your questions down, and we'll collect them and answer it at the end. Next, another distinguished panel member presenting the perspective from Los Alamos National Laboratory. It's my pleasure to introduce to you Dr. Middleton. Richard Middleton has MS in GI Science and PhD in Operational Research and Geography. He specializes in energy infrastructure modeling, developing models for carbon cap and trade, and storage, biofuels, and wind farm development. Let's give him a hand.
Okay, good morning. You can hear me okay? Yes, my name is Richard Middleton. I work at Los Alamos National Laboratory in Earth and Environmental Sciences. Today what I want to do is talk about some of the energy water projects that we've been working on, and some of the renewable energy and alternative fuel projects we've been working on. We've done things on wind, on solar. We have a few proposals on geothermal. We've done a lot of work on non-conventional fossil fuels like oil shale. And one of the themes that will be coming through this talk is most of my work these days is focused on CO2 capture and storage. So we're doing a lot of work on optimizing the infrastructure for that. And CO2 capture and storage, CCS, I think is particularly interesting for the energy-water nexus and energy-water relations because on the capture side, of course, you have increased water consumption. If we're interested in meaningful CCS, we're going to be capturing a lot of CO2 from a lot of different power plants. And if we're retrofitting power plants, which is the most likely pathway, your typical PC, your pulverized coal power plant is probably going to be roughly doubling its water consumption. So there's a very big water term on the capture end. And then on the storage end, which is what we've done more work on recently, when you're going to be sequestering the CO2 roughly in terms of pressure management and making more space for the CO2, you're going to be producing or extracting water, and that volume of water is roughly going to be equal to the amount of CO2 you're putting into the ground. And so you have a very big water problem or issue on the storage end. And so you have to make decisions. Are you going to treat that water? How are you going to treat it thermally, reverse osmosis, or you can dispose of the water, deep injection of that water. So there's a lot of energy water issues with CCS as well. Generally, I'm not going to highlight specific projects in my talk. I just want to make this more of a thought piece in terms of water-energy relationships. Hopefully I'll get through. I only have about half a dozen slides. Hopefully we can get through pretty quick and allow more times for questions and discussion at the end.